All right, so we have two sets of ordered pairs, set 1 and set 2. In which of these two sets is each x coordinate paired with only one y coordinate? Each x paired with only one y. Set 1, because in set 2, you have an x coordinate of 5 that's getting paired with two different y coordinates, right? You have 5 being paired with 1, and then 5 being paired with 2. So that's an x being paired to two different y's. So in set 1, we have each x coordinate is paired with one distinct y, exactly one y. All right, if you're going to graph lines, right, it's handy to make a little XY chart. So I'm just asking you to graph a couple of lines. So if y1 is 2x, right, so I just gave you some x values. We'll plug them into 2x and we'll get some points. So you replace the x with a -2 and you get -4. Then you get -2, 0, 2, 4. So I can plot those as points, x comma y. So I've got -2, -4, -1, -2, 0, 0, 1, 2, and 2, 4. Connect those with a nice straight line, unlike me. Okay, and then we're going to look at y2, which is 2x plus 4. So now I'm going to plug all of the same x values into a different line, 2x plus 4. So 2 times -2 is -4, plus 4 is 0. 2 times -1 is -2, plus 4 is 2. 2 times 0 is 0, plus 4 is 4. 2 times 1 is 2, plus 4 is 6. And 2 times 2 is 4, plus 4 is 8. So I have -2, 0, -1, 2, 0, 4, 1, 6, and 2, 8. Connect those with a nice straight line. Yeah, they're parallel. Yep, they're parallel. All right, so here's a graph. That is a graph of an absolute value function. All right, so what is the y coordinate when the x coordinate is 2? That is 2 comma what is a point on this graph? 3, yeah. You go 2, go up to the graph, and the point 2 comma 3 is a point on the graph. So when the x coordinate is 2, the y coordinate is 3. What are the x coordinates when the y coordinate is 4? So there are actually 2 points on this graph that have a y coordinate of 4. What are they? They've got to have a y coordinate of 4. Oh, 3 and -3, yes. Yes, so -3, 4, and 3, 4. 2 points. So -3 and 3. All right, I want to use interval notation. It's like parentheses and brackets, right? To describe the set that contains all the x coordinates of the points on the graph. Okay, so if I'm just looking for the x coordinates on this graph, what kinds of numbers are they? Negative and positive, yeah. They're not just integers. Integers are definitely in there, but there's also points between the integers. Yeah. Yep. So it would be -infinity to +infinity, right? All real numbers. Okay. If I was going to just list x coordinates of points on this graph, I would be writing down every number, right? All real numbers. What if I want to just describe the set that is just all the y coordinates of points on this graph? 1 comma infinity. The smallest y coordinate on this graph is 1, and then they go up from there. Yeah, and I'm going to put a square bracket on the 1 because that is a y coordinate on the graph, so I'm going to include it. All right, so that's a little bit of introduction to several topics that we're going to cover in the next few lessons. Okay, so we'll kind of keep those in mind. So the first thing we're going to talk about is relations. So graphing, interpreting, and modeling relationships between two variables or two sets of data is an important goal in our course. In our earlier work with graphing, we've learned that two sets of data can be represented by an ordered pair. X data and Y data, and you can pair them together and get an ordered pair, X comma Y. So for example, suppose we selected Jeff Green, Avery Bradley, Keith Bogans, and Gerald Wallace from the 2013 Boston Celtics team roster, and we listed their heights, 6'9", 6'2", 6'5", and 6'9", respectively. Right? So we could write this correspondence between names and heights using ordered pairs. So the name will go in the X coordinate spot, and then the height will go in the Y coordinate spot. Jeff Green, comma 6'9", Avery Bradley, comma 6'2". So you get the idea. So the set of ordered pairs, any set of ordered pairs is called a relation. Okay? And just the things in the ordered pairs don't have to be numbers. Okay? Any relationship between one thing and another. If you can write it as ordered pairs, we call it a relation. So the set of names, Jeff Green, Avery Bradley, Keith Bogans, and Gerald Wallace, the set of all the first component, or in the X spot of the points, is called the domain of the relation. And the set of heights in this example, which is all the second components of the points of the ordered pairs, is called the range of the relation. And remember, when you're listing things that are in a set, if something is repeated, you only have to write it once. Okay, so here's a pictorial illustration of the basketball players' names in the domain, heights in the range, and we can just relate each name to a height with an arrow. So there's just a pictorial way of demonstrating the same information that we can do by ordered pairs of points. Okay, in the ordered pairs above, we listed the name first and their heights second. However, we could easily just represent this relation by switching them and listing their height first, followed by their name. So 6'9", comma Jeff Green, 6'2", comma Avery Bradley, etc., etc. So I'm going to fill in a picture representation here with the names and heights reversed. Okay, so my heights now go in here, 6 feet 9 inches, 6 feet 2 inches, and 6 feet 5 inches. And I'm not going to repeat the 6 feet 9 inches. Right, I'll just do a double arrow somewhere. All right, so then I've got Jeff Green, Avery Bradley, Keith Bogans, and Gerald Wallace. Okay. And 6'9" goes with both Jeff Green and Gerald Wallace. So I can draw an arrow to Jeff Green and an arrow to Gerald Wallace. Okay. So when you do this pictorially, arrows always go from the domain to the range. And then 6'2" goes to Avery Bradley, and 6'5" goes to Keith Bogans. All right, now suppose that the MVP award goes to the player that's listed as 6 feet 9 inches. Okay, they're announcing it in like the Boston Garden, right? And the MVP award goes to the player who's 6 feet 9 inches. Who gets the award? I don't know. That's going to be really awkward, right? There's no way to tell who would get the award. So this is an example of a relation that's not well defined. Okay, so a well-defined relation is if you name something in the domain, you know exactly which element it goes to in the range, right? It goes to one element, right? So because I have 6'9" pointing at two different people in the range, that's what makes this not well defined. The one up here is well defined because if I say, you know, the MVP award goes to Avery, we know we can pick out exactly what height he is, right? There's no ambiguity at all. All right, so our work in this course is going to focus mostly on well-defined relations. So we're almost always going to be dealing with a relation that's well-defined. Each thing in the domain gets paired to exactly one thing. You know exactly which thing it is in the range. And a well-defined relation is also called a function. It's just another name for a well-defined relation. It's called a function. It has exactly one output value for any input value. Okay? Or, in other words, for each element in the domain, there's exactly one corresponding element in the range. So in our basketball example, if we do names and then heights versus heights and then names, which one represents a function? The first one, names and then heights. Because if you say a name, each name is paired with exactly one height. Whereas if I give a height, there is a height of 6'9" that gets paired with two different names, right? So P is a function. P and H are relations. So a relation is just any set of ordered pairs. So they're both relations, but P is a special kind of relation called a function. All right, so there's some new notation that goes along with functions. Here we have a table that lists the height of a basketball, y, at various times in seconds, x. Okay? So they represent or they define a function. We would say that y is a function of x. So generally in this class, instead of using a y, which is probably what you're used to, we're going to use a capital letter like F for function, right? And then if we want to be really creative, we might use G and H because they're the next two letters in the alphabet, right? F for function and then G and H. And then we might even get really fancy and use capital F, G, and H. So those are typically used as function names. And we represent the function using function notation, which looks like this. Instead of y, right, y is going to be equal to this f parentheses x. Okay? It does not mean f times x. It doesn't mean that f and x are being multiplied. You read f parentheses x as f of x. The input is denoted by the x, and the output is the f of x. Okay, so f of your input equals your output. And if you just keep in your head, f of x means y, right? F of x means y. It's just a fancy way of saying y. So for this particular function, input is in seconds, output is in feet, the height of the basketball. So we're going to look at how to evaluate and interpret some function notation. So if I would like to evaluate f of 2, right, this is asking us to find the output, the height of the basketball, when the input of time is 2 seconds. Okay. So we go up to our table. When the time is 2 seconds, what's the height of the basketball? 99 feet. So this is 99. Okay, so whatever number is in parentheses next to f, that's always an input, right? It's always your independent variable, your input, your x. And then what comes after the equal sign is the y value that goes with that x value. Okay. So to interpret this, we would say after 2 seconds, the ball is at 99 feet. So f of 2 equals 99 translates into a whole sentence, given the context of this problem. Okay, f of 0, what's f of 0 equal? 3. Yeah, we go up to the table, input of 0, output of 3. Right, and that means that at 0 seconds, right, so They didn't tell us what the beginning of what happened when we started measuring time. So we'll just say at 0 seconds, okay, or at the beginning, the ball is at 3 feet, height of 3 feet. All right, so here's one that's a little bit different. I've given you the output here, the 103, and I'm asking you for the x, right? So now I'm giving you a height of 103 and I'm asking you for the input x. What should I put in the parentheses there? 2.5. Let's go up. Yeah, so I found my height of 103. My input that gives that output is 2.5. So I would just write x equals 2.5 as my answer. That's like an equation. We solved it. We got x equals 2.5. And to interpret it, we would say the ball is at 103 feet after 2.5 seconds. All right, so this notation is really new. It takes a little getting used to, but it will become second nature. We're going to do tons of it. You'll get used to it. And you're going to start practicing with it right now.